Boom. Look, I remember very well we are doing the question 6, now question 7. Okay, question 7, I never explained that part because I am waiting that moment to explain. This is super easy, it's no big deal. Is determine algebraically whether the given function are even, odd, or neither. Okay. This is like a symmetry idea. It's a symmetry. Some functions have a special property, symmetry. For example, if you make a reflection, you know, is change x for negative x. If my function stays the same, unbelievable, that's true, doesn't change, the function is even. It's even because it's symmetric with respect the y-axis. Okay, one classical example of this is the function x squared. Because when you make a reflection, this negative inside the square, there's nothing because you break it down like that, -1 squared and x squared, and -1 squared as well. And when you compare this and this, wow, it's the same. It's the same, therefore, it's even. Okay, this is the definition of the even function. This statement, boom, boom, es especial because it's symmetric with respect to y-axis. Okay, another thing could happen. So you make a reflection and change, but not too much. Change is like that. What is the interpretation is? Interpretation is the reflection about the y-axis is the same of the reflection about the x-axis. Because the negative inside the parenthesis is reflection about y-axis. And the minus outside the function notation represent reflection about x-axis. So they are perfectly similar. It's the same. Okay? And when the situation happens, this function is odd. A special reflection is reflection with respect. With respect. The origin. I want to explain it in this. Origin. Origin is 0,0. Example to understand it. Suppose you have f of x equal x cubed. X cubed. Okay, so I want to prove algebraically if this function is or is not even, odd, or neither. So you will make a reflection. Always you make a reflection. And you see minus x, you replace x for negative x cubed. This is -1 cubed, and this is x cubed. And -1 cubed is -1. So when you compare this answer, boom, and this answer, it's not the same, because it's not even. But according to the definition of the odd function, look at the definition, we have extra negative in the front. Extra negative in the front. Therefore, this function is even, is odd, sorry, and is symmetric with respect to the origin. What mean that? What mean that? That means, look, in the case of the parabola, is x squared, and the case of the cubic function x cubed, the parabola, you know, look like that. And the cubic function look like that. In this case, when you make a reflection with respect to the y-axis, you see it stay the same because this branch becomes like this branch and this branch. So you rotate around the y-axis, stay the same. It's a classical even. However, no, you make a reflection, but look, this is the origin. This distance and this distance is the same. Okay, the idea is this is x, this is y, and one arbitrary point. But if you make a reflection minus x, it's minus y. And minus y represent this sign, extra, negative. This is negative. This is odd. Well, another possibility is that the function is not even nor odd. In this case, it's called neither. So basically, the interpretation of this idea is, well, even and odd are a special function because have symmetry. Okay? Different symmetry, but it's symmetry. See, we have no symmetry, that's neither. That's it. That's it. So how you prove this algebraically? Well, the key idea is replace x for negative x, and let's see what happens in the specific case out. Okay, good. Look, let's do in the first example. The first example is the function is 3x squared plus x to the 6th power plus absolute value x. I want to prove algebraically whether the given function are even or neither. Okay, I make a reflection. When you make the reflection, it's 3 minus x squared plus minus x raised to the 6th power plus absolute value minus x. And you know very well that when the exponent is even, it's positive. So it's 3x squared plus x to the 6th power. The absolute value, negative number, is a positive. You can write it. And they are perfect coincidence in the original and the new one after the reflection. Therefore, the conclusion is even. This is the proof, algebraically. Let's do it. This is A. Let's do it B. B is g of x is equal x cubed plus x plus 1. Okay, make a reflection again. Is minus x cubed plus minus x plus 1. Well, in this case, different because the exponent is odd number. So now it's 3 and 1. To say stay the sign. And we compare this and this. Wow, it's not the same. Okay, but it's not completely opposite sign. Because the one stays the same, because it's neither. To be odd, we need completely opposite sign. Suppose we have minus x squared, minus x minus 1. Entonces yes. Pero no, it's not the case. Okay? Everyone follow me or no? Come on, answer me. Do you follow me? It's easy or no?
Yes.
Okay. C. C is h over x is equal x cubed divided by x squared plus 1. Okay. Make a reflection to understand the symmetry. So it's minus x cubed over minus x squared plus 1. Well, I know the minus x cubed is minus x cubed because the exponent is odd number. However, in the bottom, no. In the bottom is even number. It says x squared plus 1. Okay. Let me try to understand a little bit. Look, this is a fraction. The numerator is negative. The denominator is positive. You can write, if you want, like that. Okay, this negative you see in the top, I put in the front. It's the same, you know. When the fraction is negative, you put the numerator negative, or denominator negative, or the entire fraction negative. And when you compare this and this, I saw, wow, we have extra negative here in the front. And this corresponds perfectly with the definition of the odd function. Makes sense or not? So this expression, I compare this and this. Is perfectly compatible of the Definition for the odd. Remember the definition of the odd was, you make a reflection, is minus the same function. So one negative outside is this negative. Super clear or confusing? Tell me. Do you follow me?
It's clear.
It's clear.
Excellent. Okay, let's do a number D. Is the last one. Number D is the last one. Is what is the letter that we using to call the function? P of x. P. The P of x is equal x squared over x to the 4th power plus 4. So you make a reflection. This is minus x squared over x minus x to the 4th power plus 4. Okay, this is positive. And this is also positive. Wow, unbelievable. Stay the same. Look. It's a classical even function. Remember, even is a function que es symmetric with respect to the y-axis. Si es symmetric with respect to the y-axis, when you make a reflection, nothing happens. Because actually it's an image. This is even function. Odd function, no. Odd function is a function que it doesn't matter the reflection that we are doing in the y-axis or in the x-axis, the result is the same. Any question on even odd? So in the test, one question, no big deal, super easy. One function is given, and you prove algebraically si it's even, odd, or neither. Okay, let's move on to the question 8. The question 8 is a typical piecewise function again, evaluate, but in this case it's easy because it's graphically. Okay, suppose this is a graph is given. Okay, and you evaluate, for example, in 4. Remember, 4 is the x value. X value corresponding with domain. I am trying to find 4 on the x-axis. Here, this is 4. Boom. Just my goal is find the y value associated with this. In order to find the y value, you go to the graph. Well, at the beginning, I don't know. Maybe it's over or downward. So in this case, it's over, obviously, right? And you touch the graph here, and the value associated in the y is 6. Because the reason is clear. I discover one point on the graph of that function is 4,6. This is the x value, and this is y value, right? Be careful, because in my graph, you have, for example, you have a holes. We have maybe a gap. In this case, no gap. And so okay, you need to extra hole because it's completely out of the graph. And this is where you're using your imagination, no, and your common sense. For example, -2. Where is -2? Well, -2 I suppose to here. Yeah. I don't have that value. However, in what direction I go? I go over or downward? I go downward because I want to touch the graph. But I have no idea what is this value here. But using my common sense, see, this is a line linear function, and this is a -1. It's obvious that this is -2 because it's linear. The point is -2, -2. So you don't need to write that part. No, it's not important. The answer is this. I suppose that the result is a y value. The F evaluando. Everyone follow me? It's easy or complicated? 2. Oh, 2 is a complicated guy because I don't know si I take this value of the y or I take this value. It's obvious I take this because I see that this circle is closed and this circle is open. That the value is 4. Guy, everyone follow me?
Yes, Professor.
Say again? I don't hear anything. Using the chat if you want to communicate. The microphone doesn't work. Your microphone is no good. Pero using the chat. Yes. And Lance said yes. Okay, Alan, appreciate so much your comment. Let's do it. Number 0. Look at 0, 0, 0. Well, 0 is the origin. Boom. Here, 0. 0,0. Nice. -1. Oh, -1 is complicated guy. Because -1 here, but I have two options, over or downward. It's obviously over because this circle is closed. Entonces 1,1. Look at this value is 1. 1. Okay. -4. -4 here. -3, -4. Again, si es linear function, I suppose standing here mentally is a -4. Okay, -5, it's the same. It's -5. +5. Oh, no, this is different. +5 here. Again, it's 6. And +6 and +7. I have no idea. 6 here, 7 here. I suppose that function continue constant. Entonces 6, 6. Clear? Let's evaluate piecewise function, pero graphically. No.
Yes, it's clear.
Okay, super. The question 10 is determine domain and range of the function from the graph. Express the answer in interval. Okay, let's do it. Be careful, because in the graph contain holes, gap, in which obviously the function is undefined. Therefore, it's totally outside the domain.
Wait, it's supposed to be question number 9.
This is my mistake. And number 9. You're right. Number 9. No 10. O sea, 10 is missing. Okay, entonces let's focus it in the graph. Let me make it zoom to see more clear. Boom. Remember, what's the idea? The idea is you have a graph. You pick arbitrary point on the curve. And you're projecting this point onto the x-axis if you want to investigate domain. Because one more time, I repeat, domain is the x value in which the function is defined. So it's undefined, it's complete out the domain. But I can see some problem in 2, because in 2 I saw a hole, and in between 2 and 3 I saw a gap. Okay, so my domain, what you're projecting, look like that, I suppose. That part is okay, stop. That part is okay, stop. Okay, I extending a little bit. It's from 3 to infinity. Okay. This is important. Look, this is from negative infinity. And 2, we have parentheses because no included, it's undefined. And 3 is bracket. So what's the answer? The answer is our domain, but wait a second, and this continues forever to positive infinity. Our domain is from negative infinity, comma 2, parenthesis, union, bracket 3, comma infinity. This is our domain. Okay, projecting onto the x-axis. And the range is projecting onto the y-axis. Let's say you're projecting onto the y-axis. Well, let's do it. Is the any point on the curve you projecting onto the y, I can see, because this line continues forever down to negative infinity. Here and 2 is okay, but and 3, and 3 is parenthesis. because do not include because this circle is open. Okay, entonces our range is from negative infinity, comma 3 parentheses. We have no range. We have no y value in 4, 5, 6, 7. So it's only the part that I highlight in blue color. Any question? One question similar you see in the test. The graph is given, and you need to determine the domain and range graphically. Everything okay? Sure, everyone follow me, no problema. Remember, this is review. Entonces in the review, we are doing fast. Angelica. In the review, we are doing fast because you see somehow before this idea, but I want to reinforce the concept, no? Because I would like you to be ready to do the test. Okay. Okay, let's move on to the. Okay, let me see. It's page 3, I guess, no? A ver. Oh, yes. Okay. It's a question, actually, is that 10 is missing, remember. It's a question 11. Question 11 say, two functions is given. Okay, let me rewrite again. F of x. We are doing 11 now. F of x is given is 7x squared minus 6x. And g is x squared minus 2x plus 24. Okay, now they want you find the expression that corresponds with the function que is a combination f and g in that way. F division g of x. And the complicated part is states domain. Okay, this is the easy part because you copy f in the top. You copy g in the bottom. And end the story. But the second part of the equation is states domain. Okay, I remember one more time. The domain, the supposition is all real number. You assume all real number except the restriction. And the restriction is, suppose restriction number 1, remember P divided by Q, and Q must be 0. In this case, it's applied this idea because it's division to function. Because I need to investigate x squared minus 2x plus 24, non-zero. Okay, you take the expression in the denominator and you enforce it to be non-zero. This is inequality, but I want to convert to equation because it's easy for me. Okay, entonces now I know that the solution of this is the restriction of the problem because this is a negation. Okay, entonces this is quadratic equation. I don't know si es possible or not by factorization. I suppose que no. By quadratic formula, let's do it. A is 1, B is -2, and C is 24. Entonces now es minus B, que es doble minus, es plus 2. 2 plus or minus square root -2 squared minus 4 times a get 1 times 24 divided by 2 times 1. As always, we focus in the expression inside the bracket. -2 squared is 4 minus, wow, 24 times 4 is 96. It's obvious. I don't care what value is 92. 92, no? It's -92. But the square root -92 is imaginary. It's I. Radical 92, I don't care that value. The important thing, you stop. You understand that the thing that you try to find is restriction don't belong to the real number. It's imaginary number. Therefore, the conclusion is the domain is all real number. So you state the domain of this function is all real number. To be, okay, let me repeat again the idea. To be imaginary means is in the real field do not exist restrictions. Therefore, the domain is all real number. Makes sense or no? Do you understand this idea? Okay, this is a classical algebra. In algebra, when we are working in the functions questions, you assume that our domain is all real number. Sometimes happens that we have restriction. Okay, it's a bad guy in which the function is undefined. So I try to investigate, apply the idea for the restriction. When you get imaginary or complex, that means that this restriction that you are looking for do not exist in the real field. Therefore, the domain is all real. Make sense? Yes or no, guys? Let me know. I explain in different way.
Yes.
Okay, good. Jasmine always help me. Okay. 12 question. 12 question again is a combination for the function. Function is f of x, is 2x squared plus 5. And we have another function is g, is x plus 6. Oh, easy, linear, and this is quadratic. And you need to compute f plus g evaluate. Wow, this is piece of cake. This is equivalent to say f evaluate plus g evaluate. So let's compute it separately. Fn3 is 2 times 3 squared plus 5. 3 squared is 9. 9 times 2, 18. 18 plus 5 is 23. Okay, this is this answer. This answer is 23. And G is easier, is 3 plus 6 and 9. And 9. And 23 plus 9 is 12, carry that one, 32. Boom, super easy. One question you see in the test like that. I don't know if it's addition, if it's subtraction, or multiplication, it's combination. Two functions is given. And you need to evaluate the combination. I don't know, see in the test I put minus here, or time, or division. Okay, it's an arithmetic operation. This is super easy in the test. Okay. Okay. I suppose that you have no question, no? Okay, let's focus in the question 14. The question 14 is a little bit long. It's about the compute the famous different quotients, the famous different quotient of the one specific function, and always is the same, it's quadratic function. So don't complicate your life. So this function is given is x squared minus 5x plus 6. And I need to find the famous different quotient. Okay, the formula is x plus h minus f of x divided by h. Let's do it step by step. It's too long, but it's easy. You first of all compute x plus h. In other words, let's replace x for x plus h. Leave it like that, no? No, you foil here, foil. You foil here. Entonces es x plus h times itself is x squared plus x times h plus x times h again plus h squared. I foil. And here I apply these three with the property. minus 5x minus 5h. And this 6 just bring down. We combine like term. X squared, this and this together is twice, 2 times xh plus h squared minus 5x minus 5h plus 6. Okay, here I have in my hand the first piece of the formula. Okay, now the second piece of the formula is subtracting the original. So you take this minus the original. I copy again. I copy. X squared plus 2xh plus h squared minus 5x minus 5h plus 6 minus the original is given. And the original is given, look here, is minus, so this minus here, when you apply here in the front, change the sign, that you put like that, minus x squared minus 5x plus 6. But no, it's much better. Change the sign, and that's it. This is minus x squared plus 5x minus 6. Super. Now, in this moment, a lot of people is canceled. Look, 6 is canceled. 5x is canceled. And x squared is canceled. And stay alive only 2xh plus h squared minus 5h. Okay, finally, you divide by h, because this is the result of x plus h minus f of x. Divided by h is super easy, because it's a monomial, and monomial you divide 1 by 1 by h. And thus this h is cancelled. Look, multiplication and division. This is cancelled also. Well, this is cancelled by only 1. So my final answer is the 2x plus h minus 5. Boom. End the story. Okay. Yeah, I want to see in the test on paper the process step by step. Any question, guy? No, no problem. You understand very well. Come on. This is the moment to ask me any question, please. I have time. I have all the time of the life to explain everything. This is clear, confusing. Come on, opinion. Clear? David?
Clear.
Okay.
Thank you.
Okay. Angelica, Juan?
Yes.
Okay. Juan Gomez. Okay. Well, let's move on to the next question. Next question is find the distance. Remember, distance, 2 points is given, P1, P2. P1 is 3 radical 10. So normally expecting a complicated irrational number in this question. P2 is 5 radical 10, comma 1. And the distance between P1, P2 segment is the formula, distance formula. And distance formula have x2 minus x1 squared plus y2 minus y1 squared. This is our formula, distance formula. Who is x2? This is x1, is the x component, y1. And this is x2, y2. So just plug it in the formula. Okay, x2 is 5 radical 10 minus x1 is 3 radical 10 squared plus y2 is 1 minus y1 is negative 2. So we have double negative, that negative, and that negative together become positive. Square. Okay, let's do it. Subtraction, the x part. 5 radical 10 minus 3 radical 10 is 2 radical 10. And remember, when you combine two expressions that contain radical, see the radical is the same, nice. The only thing you should do is combine the coefficients in the front, the 5 minus 3, boom. And when you square this guy, it's a monomial expression, so it's 4, so it's 2 squared, let's do it step by step. It's 2 squared times radical 10 squared, no? And 2 squared 4, and radical 10 squared 10. This is the answer 40. At least the answer of that part, including the square, no? Is 40. The answer for the second part is 3, and 3 squared 9. Wow. And 40 plus 9 is 49. And the square root, the biggest square root you need to compute in the last moment is 7. The answer is 7 in this case. The distance between that point is 7. 7, I don't know, 7 inches, 7 centimeters, 7 miles. It's not important the unit. The unit is not given. It's 7. Any question? Distance formula. One problem in the test. Super clear. Okay, let's move on to the 15th question, that is midpoint. Midpoint is, in my opinion, it's easy. It's easy. Midpoint is easier. Midpoint. What is the formula for the midpoint? Well, the formula for the midpoint is, let me recall. Midpoint formula. Look, the 2 points is given again in this problem. The only tricky part is que the number is in decimal. Pero eso, que we use a calculator if you want. 4.2, comma, negative 7.8. P2 is 1.7, comma, minus 3.2. Entonces the question says find the midpoint. The formula for the midpoint is x sub m, midpoint, x1 plus x2 divided by 2. Likewise, y sub m, is the y component of the midpoint, is y1, 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 y1 plus y2 divided by 2. So it looks like an average in the component. Entonces, for, bueno, who identification? This is x1, y1, this is x2, y2. So basically, it's 4.2 plus 1.7 divided by 2. And the y component is y1 is minus 7.8. Bueno, es plus, pero es plus and minus, es minus then 3.2 divided by. Okay, entonces put in my calculator, why not? 4.2 plus 1.7 is 5.9. It's obvious. Divided by 2 is 2.95. Boom. And likewise, 7.8 plus 3.2. It's plus because it's the same sign. You add it, it's 11. It's negative 11 over 2. So negative 11 over 2, I suppose que it's 5.5 divided by 2. In my calculator, yes, negative 5.5. So what is the final answer? The final answer is midpoint is located at the point 2.95, comma, negative 5.5. Is the answer. Any question? Midpoint. No problema with the midpoint. Easy, easy, easy. Super. Okay. Does everyone follow me? How do you feel in this topic? This remember, this is traditionally what I teach in this class. The test number 2 is hard. A lot of people fail. I don't know why. And the test 4 is the hardest test. But the test 2, you know, I suppose the problem is it's too many graphs, and the student don't understand very well the graph. I don't know. I don't know. Okay. So in 17 say, write the equation of the circle in standard form. Okay. The equation of the circle is given. It's given. Let me rewrite again to see more clear. X squared plus y squared plus ax plus 4y plus 16 equal to 0. This is equation of circle. But the only problem is it's expressed in general form. But in general form, I don't see anything expressed in general form. In general. To see more clear, we need to convert to a standard. Because in the standard, you can see where the center and where the radius. So the process we are doing is now completing the square. You separate the x and y, let's do x squared plus ax separately, plus one box, and that box is the magic number that completes the square of this trinomial. Likewise, you organize the y part. Thus, in the right-hand side, I move negative 16 plus 2 boxes. Okay, the box I introduce artificially inside our problem in order to convert the completed square. Boom, boom. Okay, do you understand this organization?
Yeah.
It's classical. Does I need help? Who helped me with the first number? This one. Boom. What is that? What is the formula to complete the square? It's b divided by 2 square, no? Entonces, b in our first trinomial is 8, no? 8 divided by 2. Go ahead. I don't hear. Come on. Repeat again, please.
8 divided 2, 4 square, 16.
Excellent. 16, she said. 16, she said. It's 16. You're right. 16 is the magic number that completes the square. 16, you put 16 here, and you put another 16 here. In order to doesn't affect my equation. No? And what about the second? The second trinomial. Y squared plus 4y plus something. What is the magic number here? 4. It's a coincidence, the 4. 4 divided by 2 is 2, 2 squared 4. It's 4 and 4. Super. Now, I know very well this trinomial is perfect square, and the factorization, this guy is x plus 4. Why 4? Where come from that 4? It's square root 16. And x is square root this. Plus. Everyone follow me? Plus. Y plus 2. Where come from 2? Square root 4. In the right-hand side, you have just 4 because this and this cancel out. Okay, ready. This is now equation for the circle expressed in standard. Standard form. Nice. Highlight that. And standard, you see clear center, and radius. Okay, be careful with the center and radius because the center is h comma k. Let me compare. This is x minus h squared plus y minus k square equal r squared. And the center is h comma k. In general, no? H comma k. And the radius r, little r. So what is the, in our specific example, what is the center? It's located at the point. Be careful with the sign. Is, help me. No idea?
-4 and -2.
Absolutely perfect. -4, comma, -2. Be careful, completely opposite sign. Because in my equation, you see negative. But in my specific example, I see positive. Why? The reason is because the value for the h and k are negative, and double negative become positive. Wow. And what about radio? And what about radio? And what about radio? Well, radio is, you know, this side.
4.
F4 no. R squared F4 is. Therefore, R square root both sides
2.
is 2. Okay, I agree.
2.
I agree. This is the most important conclusion. Okay. Okay. Be careful. Center, opposite sign. And the point and the equation. And radio is the square root of the number that you can see in the right hand side. In standard. See 4, you apply square root, it's 2. And that's it. No, because they want that you are doing the graph of this. You are doing the graph. Let's do in the graph now. But so far, everyone following or no? Let's do it now, a graph. Graph of that circle. Let me enlarge it. Okay. Because the only information I need is the information that I highlight in blue color. I plot the center. I plot the center. The center is -4 x -2 y. Here is the center. Boom. That point is this point. And 2 in any direction is a radius. Remember the fundamental direction is upward, downward, right, and left. Entonces, 2 over 2, what's that? 2 here, 2 down, 2 to the right, and 2 to the left. Okay, now I using another color, maybe red, and try to connecting this point using our best intention to look like a circle. Boom. And it's the final answer. Okay, the question is complicated. This is an important question on the test. This question, the value for this is 10 points because it's too long. Number 1, complete the square. Number 2, find the center radius. Number 3, do the graph of the original circle. Any question? Any question? Okay. No? Sure?
Question.
Excellent. Okay, I like the student ask me a question. Of course, you ask me a question when you have doubt. You understand very well, no problem. No necessary question. Okay, now let's move on to the last page. Last page. Last page. Okay, last page is several problems about domain when you have equation in your hand. No? Suppose you have equation, several equations. I need to complicate, but on the test, no. On the test is relatively easy. For example, let's do it in the first one. The first one is, okay, I want to copy one more time the idea for the domain. When you have equation, you assume okay, the domain is over a number. except restrictions. And the restriction, we have three classical, and they are combination, of course. Division, you need to investigate the expression at the bottom is not zero, because I know the division by zero is illegal. Radical, you need to investigate the expression inside the radical must be non-negative, because it's negative is imaginary. It's out of the domain. And when it's a radical, but in the denominator, you need to investigate the value in which the expression inside the radical must be positive. Because zero, no, because square root zero is zero, is real, but division by zero is the same problem of the first. Keep in mind this restriction, and you apply in any expression. And suppose you have more than one restriction, so you put together, so like and, so you must satisfy this restriction and this restriction and this restriction. Okay, restriction. Okay, and the number A is super easy because it's 4 divided by radical x minus 3. This corresponded perfectly with that restriction. Yes or no? This one. So you take the expression inside, is x minus 3, and you enforce it to be greater than 0, positive. X is positive. Okay, this is the answer, right? However, they want an interval notation. Always in the test, declare the domain using interval notation. It's obvious, okay, interval notation, this is equivalent to say parenthesis 3, infinity, no? You understand this or no? No? Okay, you have some doubt? No problem. You understand using the number line. Okay. This is infinity negative. This is infinity positive. This is 0 in the middle. And 3 is 1, 2, 3. And what direction? Well, I suppose it's to the right because it's greater than 3. And of course, the problem do not include 3 because I don't see any equal sign. No equal sign. That means it's parenthesis. It's from 3 to infinity, exactly the same idea. Any question? Any question? And number 8. Done? No problem. Sure? Okay, so I need help for the next. It's complicated a little bit. Suppose, how many restrictions you see in B? How many? How many restrictions you see in B? 1 restriction, 2 restriction, 3 restriction. How many? How many? You see one. 2 restrictions. Okay, 1 restriction like that, and the radical in the denominator, and another restriction like that in the numerator. Exactly. Therefore, the set or the setup for the restriction is x plus 5, the expression inside the radical and the numerator must be greater than or equal to 0 using this idea. Look. However, we have another restriction is 6 minus x greater than 0. Is this idea. And how we connecting both restrictions? Well, we connecting by and. Because you need to satisfy this inequality and this inequality, both. Entonces, in this moment, the problem, the algebraic problem you have in your hand is compound inequality, and that's it. Let's solve it. How you solve a compound inequality? Well, okay, I explain again. You solve it separately, both. X greater than or equal to -5. And move 5 to the right-hand side. Done. In this case, well, you move 6 to the right hand side. Minus x greater than minus 6. But by negative 1, both sides. X is, remember when you divide by a negative number, the inequality is reversed. It's greater than, no, it's greater than, no, it's less than, sorry. Less than 6. Okay. So we have two pieces of information. It has always happened in the compound inequality. In order to see more clear, my recommendation is do the line. Do the line. Or real number line. This is infinity positive. This is infinity negative. 0 in the middle. I suppose using my imagination get this is negative 5. I suppose using my imagination get positive 6 here. Entonces I'm doing the graph of these intervals separately. Okay, entonces from negative 5, in this case to the right, no, because it's greater than. It's greater than. It's greater than. Include 5, yes. Include 5. The symbolic way to indicate this idea is bracket here. I did the graph of this part. Doing the graph of the second part. Get this. This is less than. Less than is to the left. So to the left. From 6. Let me try to, in order to doesn't confuse you, not necessarily overlap this. I put here. From 6 to the left in that direction. This continues forever, of course, to negative infinity. And here we have parentheses. Because no includes 6. Okay, so now my problem is and. My problem is now and is intersection. I need to find the common element in between the blue and the green. What do you think? What is the common element? What is the element that share both intervals? Green and exactly. Very well. This is the answer. The answer is bracket negative 5, 6 parentheses. End the story. This is the domain of that function. Another value, complete outside, is undefined. Maybe it's undefined because you get, for example, let me try to understand more. Suppose I pick 7. I try to evaluate the function g in 7. Let's see what happens. It's square root 7 plus 5. I plug in here. Replace x for 7. Divided by square root 6 minus 7. And the top, we have no problem. Remember, the top represents the blue part. It's a real number. But in the bottom, no. And the bottom is imaginary number because 6 minus 7 is negative 1. Square root negative 1 is I. Suppose I pick another. Suppose I pick negative 6 here. It's completely out of the domain. When you the answer is undefined here. Undefined. Because this is imaginary. And negative 6. So you evaluate g and negative 6. I don't know what's going on. Well, it's negative 6 square root. Negative 6 plus 5 divided by square root 6 minus negative 6 is positive 6. Okay, so in the radical and the bottom, we have no problem. The problem is in the radical and the top. It's negative 1, again, undefined. The same situation, undefined. Do you understand very well now? But this is double check it, but I don't need to do that. The answer is this. It's perfect. Any question? This is our domain. Super clear? Or very confused?
Can you please explain again the undefined? Why is undefined?
It's undefined means because look, We have radical 12 because 7 plus 5 is 12. And we have radical negative 1. And radical negative 1 is I, by definition, if I is completely out the all real number set. That is the reason que es undefined. Clear?
Yes, Professor, thank you.
Like what happened in the 6 and the negative 6, because this is square root negative 1, because minus 6 plus 5 is negative 1 divided by radical 12. This is I, again, radical 12. Totally undefined because participate I. And I is the quantity completely out the all real numbers. Living in another planet, maybe in Jupiter. No planet, dimension. It's another dimension. Okay. Don't B. With the B. Any question? Everyone understand B? Entonces, I need participation for the rest. Okay, you guide me. You help me. Okay, you try to discover how many restrictions, what kind of restriction, what formula using. Look. Let's focus in C. C is the function, the equation que es given, que es 8 over square root x plus 3.
Okay, so
Go ahead.
in C, I see two restrictions as well.
Only two?
One in the first part of the equation, there's E over the square root of E, and then on top of that, the second part is two of them combined. Square root of E, and then you got at the same time P over the square root of E.
Super. Okay, entonces one restriction just means so here. Entonces es x plus 3 greater than 0. ¿Es correct? And another restriction here. X plus a greater than 0. And another restriction is here. But this is different because it's in the top. It says x minus 4 greater than or equal to 0. Do you see that? Wow, amazing, easy. You recognize the restriction? Well, those are the rest is compound inequality. Remember, compound inequality, you solve the one by one separately. This is x greater than minus 3. Good. One piece of information. X greater than minus a, another piece of information, and x greater than or equal to 4, third piece of information. Well, using the number line to visualize more clear because it's confusing, this 3 interval. Okay. This is infinity positive. This is infinity negative. This is 0. I suppose it's negative 1, negative 2, negative 3, 4, 5, 6, 7, 8, negative 8, and positive 4. 1, 2, 3, and 4. Okay, let's use in color. For this restriction, is from 3 to infinity. It's yellow. Continue forever in that direction, and here parentheses, no including negative. For this restriction, es negative. Entonces no put it on the line because it's confusing. I propose you doing that way. From negative 8 to this. Okay, entonces continue forever. In this case, parenthesis also because I don't see equal sign. Good. And the last one is this. Well, it's from 4 to infinity, no? In that direction. Okay, so say 4, 4. And this case, yes, include 4 because it's equal. See? Do you follow me? Entonces, what is the interval que satisfy green, yellow, and blue? What is the final answer? Domain. Tell me.
1 to the infinity.
Exactly. Bracket or parenthesis, miss? She said from 4 to infinity.
Bracket.
Bracket is the final answer. This is our beautiful final answer. Any question? Do you understand very well? Super, super. We are the best in Miami-Dade College. Okay, done. Number 6. Oh, question 6, sorry. Okay, we have 2 more. 2 more interesting and complicated and confusing and tricky. Boom. Okay, suppose now this expression is 8 divided by x minus 3 plus square root x plus 5 divided by x minus 4. Wow, this is how you set up restriction in this case. Tell me, how many restrictions you can see? How many? And which kind of restriction? Let me recall again. Restriction number 1, p divided by q.
That's what restriction number 1 I see in the first part.
Que is denominator expression, que es x minus 3, non-zero, illegal, right?
Yeah.
One more.
I do see restriction number 2 on the numerator of the second part.
Exactly. Que es x plus 5 greater than or equal to 0, correct?
Yeah, and then on top of that, there's also another you'll also see it combines with restriction number 1 as well.
Excellent. Restriction number 1 as well. So say we have another and, because I see 3 restriction is x minus 4. Correct? This is the setup for the restriction. We have one more time, compound inequality, we solve it one by one. X not 3, x greater than or equal minus 5, and x not 4. And this is a little bit special because when you have no greater than or less than symbol, you have no equal. That means in that specific value, 3 or 4, we have a whole. We have a whole. This is my Orion number line. Look at that. The 0 here in the middle. 1, 2, 3, and 3, we have a whole like that. Look. Boom. A whole. In 4, we have another whole. It's 4. We have another whole. Boom. Do you understand this? That means it's all real number. So what is the graphic of this separate? Well, I suppose case look like that. All real number, suppose case yellow or blue, sorry. All real number. Okay, this is positive infinity, negative infinity. But specific entry is here, 0, 1, 2, 3. We have a whole, no? And the whole is something like that. Boom. We have a whole. Okay. Okay. Do you understand this? Basically, this guy and this guy represent two holes. One hole in 3 and one hole in 4. Okay. And 4. And what about 5? Negative 5. Negative 5. Let's say negative 1, negative 2, negative 3, negative 4, negative 5. Negative 5 is here. It's graded down. It's graded down. So now I see it's graded down, but let me use a different color. Yellow color, maybe. You know, first of all, and close the box this. And the yellow color for this is from negative 5. But the problem is, wow, we have a hole, we jump the hole, and we continue. Okay, this is easy to understand. This is a bracket, of course, because I saw equal sign here. I saw because here parenthesis, because don't touch 3 and 4. And this continues forever to infinity. Okay, so what is our domain? What is our domain? Who helped me to write the final answer of the domain? Domain is from to. Tell me. But it's easy.
Bracket.
Bracket what?
5.
Bracket negative 5, comma.
3.
Parenthesis or bracket?
Parenthesis.
Union. You using union symbol when you want to connecting different intervals separately. What's the next interval?
Parenthesis 3, comma 4, parenthesis, and U, parenthesis 4 to.
Super, super good. This is the final answer. Super good. Super good. Any question, guys? Super good. Any question? No? Do you understand very well this? This is look like complicated at the beginning. No, but no, actually it's not complicated. Okay, because you know the restrictions. The restriction is the expression. Okay, give me information about when the function is undefined. We have 3 kinds of undefined: division by 0, radical at the top, non-negative, radical at the bottom, positive. And their combination, and their combination, and their combination. Let's do in the last one. Case square root x plus 2 plus square root x minus 2 plus 1 over x minus 3. Who will be able to set up the restrictions in that case?
Okay.
Go ahead.
And in the first 2 parts, there are restriction 2, and
yes.
The 3rd part is restriction 1.
Exactly. So this is x plus 2 greater than or equal to 0, and x minus 2 greater than or equal to 0, restriction 2, exactly, just may say, and x minus 3, no, 0. And remember the interpretation, this guy, the interpretation as a whole. Okay, let's try to solve it one by one, this inequality, separately. X greater than or equal minus 2, x greater than or equal to positive 2, and x not 3. And this represents 4 and 3. Okay. My Orion number line. This is important. You know, when you study compound inequality in intermediate algebra, always you ending the compound inequality graphically, because we have several, several inequality, but you put together graphically to see much better. Okay, this is 0. This is 2, 1, 2. This is negative 2 here. And this is positive 3. Well, and positive 3, I know, okay, we have a hole. Boom. We have a hole. Okay. Okay, so let's do it one by one. Suppose this. I highlight this in yellow. And negative 2 is in that direction. But be careful here. Stop, because we have a hole and continue. Okay, so this is bracket. It's obvious because we have equal sign here. Look, it's a bracket. I think we are bracket. Bracket. Let me make it so too small, more clear. No, not too much. It's okay. Bracket. It's obvious. Well, no, I don't care. Bracket for a moment, temporary. Now let's move on to the second one. Is this? Let me use some blue color. Blue. And this is from 2 to infinity positive. But it's obvious if we continue the same hole in 3. This is not good. It's from 2. Stop here. Continue. This is bracket again. And this is continue forever in that direction. I forgot continue forever in that direction. Okay, remember we have a hole, and the interpretation for the hole is hole in both cases, parenthesis. So what is my fantastic conclusion of the domain? Intersection. I need to intersection the yellow part and the blue part. Bracket what?
Negative 2.
Remember, it's and. It's the common element. What is the common element between the yellow and blue? Negative 2 participate in the game, or we start in positive 2? Look. Don't lose the idea que es and. I need to find the common element. Es obvio que these guys belong to the yellow part, pero no belong to the blue part. So I need to satisfy blue condition, yellow condition, and the whole. Okay? So the common element is obvious start in positive 2. Because 0, negative 1, positive 1, no, it's yellow, pero no blue. Entonces 2 something, 2,3, no? In 3, remember, we have a hole. Union, 3, something like that. It's okay or no? Oof. Okay. No. Well, so we have time. I don't want to complicate. I don't want to start chapter 3. No. Let's wait into Friday to start chapter 3. Chapter 3 is easy, guys. Study. Try to any question that you have. Remember. The due date is Friday. This Friday. Que es 12, November 12. This day, you send me by email the test on paper que I sent today in this email. And the email I sent today. And submit, please, the homework and test 2 online in Alex. Okay? Okay. Everyone is clear, confused?